In this video, I'm going to cover section 2.7, independence. So let's see. So last time we learned about the multiplication rule and then total probability rule, right? So we could figure out the probability of event using the conditional probability, right? So now here, then look at the independence. So in some cases, the conditional probability P of B bar A might equal P of B. So what circumstance we're going to get this? So now in this special case, knowledge that the outcome of the event experiment is in event A does not affect the probability that the outcome is in event B. It makes sense, right? So what does that mean? Condition probability. So the P of B bar A means that probability event B occur given that event A is already occurred. But what if probability of that event B occur will not be affected by probability of event A? Then the PB bar A should be equal to P of B. So let's see example 2.21. So to better understand, sampling with the replacement. So when you see that with the replacement, I'll tell you later, but when you see problems mentioned about the with the replacement, then most of the problems is about are going to be problem about independence. It means that conditional probability just equal to, I mean, is the POB bar A is just going to be equal to POB in most of problems. But we'll see. Consider the inspection described in example 2.11. So please go back to example 2.1, just read it, okay? So 6 parts are selected randomly from a bin of 50 parts. And then, but assume that the selected part is replaced before the next one is selected. So the bin contains 3 defective parts and 47 non-defective parts. So you see that assume that selected parts is replaced before the next one is selected. So replacement a lot, right? So it means that the total number of parts going to be remain as 50 because when you just pick the one bin and then look at it, check it, and then put it back. Okay, so total outcome sample space. I mean, the probability that what we choose defective part or non-defective parts in second try will not be affected by the probability that we did in first try. So what is the probability that the second part is defective given the first part is defective? So then you see, first one, the see that the what is the probability the second part is a defective part? So how many defective parts in the sample space? 3, because you see that the bin contains 3 defective parts. So 3 out of 50, that's going to be probability that we select defective parts in second part. Okay, and then the first part is a defective. That doesn't make sense. That doesn't that will not be affected the probability that we selected defective part in second time because replacement allowed. Okay, so P of B bar A gonna be 3 or 50. Okay, so now then, so the probability that both parts are defective is gonna be what? P A intersection B gonna be P of B bar A and the P of A, right? But since replacement allowed, so 2 events are completely independent. So PB bar A gonna be just P of B. So 3 of 50 times 3 of 50, this is 9 over 250, 2,500. Okay. So now see the it's still right here. So now we got this P of A intersection B turns out to be what? P of B and times P of A. It means that and because P of B bar A turns out that what P of B. Okay. Now then, so what? Then the what so in that some situations, then what happened to the multiplication rule? So P A bar B conditional probability can be expressed as P of A intersection B or P of B, right? And now you see that top one, P of A intersection B, we just got this P of A intersection B is equal to P of B times P of A. So the top one can be expressed as P of A times P of B. You see that P of B cancel them out, so we got P of A. So that's the answer. Yeah, algebraically, we could express P A bar B is equal to P of A if 2 events are not effective each other. So So in that case, two events are called independent, by the way. Okay, it means that conditional probability P of A bar B equals P of A, or P of B bar A is equal to P of B, and then P of A intersection B is equal to P of A times P of B. Okay, so and then it is and then also we see, I'm not going to prove this, okay, but P of A prime intersection P prime is equal to P of A prime times P of B prime. Okay, so oops, give me a second. So okay, so in summary, it's please do not confuse with the independence and mutually exclusive. So mutually exclusive means that P of A union B is equal, can be expressed as P of A plus P of B. It means that A intersection B, common outcomes, there is no common outcomes. So A intersection B is empty set. Independence means P of A intersection B is equal to P of A times P of B. It means that P of A does not affect on P of B, or vice versa. So mutually exclusive is regarding the P of A union B, and the independence is about P of A intersection B. Keep in mind this. So let's take a look at the example 2.22, and then other example 2.23, 2.24, and then 2.25. Just read please read those example by yourself. Okay. So example 2.2. So consider the inspection described in example 2.21. 6 parts are selected randomly without replacement. See the without replacement? Then you have to apply the independence. Okay. So from being of 50 parts, oh, the without replacement. Sorry. Then Then two events are not going to be what independence. So because replacement is not allowed. So the bean contains 3 defective parts and 47 non-defective parts. Let A and B denote the event that first and second parts are defective. Okay, so first and second parts are defective. So then what? A probability that is that the second part is defective will be affected by the probability that affected by the first event, right? For example, if it's just first event, first event we event A. The first part, if first part is defective, then the probability that when you choose the second part, since we already got defective part in the first try, so the total number of outcomes, defective parts going to be reduced by 2. Um, 2, right? Okay. So now see, we suspect that these two events are not independent because, yeah, I told you, right? So now let's see. Let's figure out POB. Okay. So now then, let's see. Okay. So using the total probability rules, okay, let's find the POB. Then we could express POB as POB bar A times P of A plus POB bar A prime times P of A prime, right? So it was second. So I just drew the Venn diagrams. Okay, so what's the event A is the probability. Event A is the first part. We choose 6 parts, but first um what? Let me see. First part is defective, right? Okay, so now this is going to be B intersection A. This is B intersection A prime, right? So in total probability rule says that P of B is equal to B, uh, yeah, B bar A times P of A, right? Okay, and then plus B bar A prime times P of A prime, right? Okay, so now let's figure out this B bar A. Okay, let's see B bar A. So probability that, okay, so PB bar A is the what? Probability we select the probability the second part, okay? second part is a defective, given that first part is also a defective. So then we just select the first defective part in the first try, right? So that total number of the defective parts reduced by 2, and then total number of outcomes reduced by 49 from 50. So the probability we choose a defective part in second try gonna be what? It's gonna be 2 over 49. Okay. Then what about probability A? 3 over 50, right? Okay. And the plus P of B bar A prime. What's an A prime? A prime is what? Uh, gonna be 47 over 50, right? So here A prime. Okay, this is gonna be 47 and 50. Now then, what about this probability that we choose a defective part, given that A prime means that we don't choose defective part in first try. Okay, so this is gonna be just 3 over 49. What does that mean? So think about this. Event A occurred. A prime occurred means that we in the first when you choose the first part, that part was non-defective part because A prime. So anyway, one part is we choose one part. We did choose one part in a in the first try, so that total number of outcomes gonna be reduced by 49. But that is not what defective part, which means a non-defective part. So total number of defective parts is still, remain as just 3. So the probability that what we choose the defective parts in second try gonna be 3 over 49. And then AP of A prime gonna be 47, right? Over 50. Because P of A prime means that what probability that we choose non-defective parts in first try, 47. Okay. So that will equal to 3 over 50. Okay. So give me a second. All right, so now we could extend the concept of independence to multiple events. So E1 through the En are independent. It means that probability of intersection E1, E. I think give me a second. C1 through, yeah, I think this is a typo. Actually, this is E1 through the En. Okay, so give me a second. Oh, I'm sorry, never mind. So any subset, yeah, even independent if and only for any subset of these events. So EI1 means a subset of E1, and EI2 a subset of E2. Okay, through the EIK. EIK means a subset. Oh, yeah, sorry. Yeah, never mind. I was confused. So EI1 through the EIK are any subsets among the EI1 through E1 through EN. Okay, so this is probability of the intersection of these subset is equal to the multiplication of the probability each probability. Okay, so now example 2.23 to E.25. So just read the example by yourself. Okay, so next time I'm going to cover 2.8 and 2.9.